Hello! How's it going, everyone? I will get it again here, looking at the React performance course as a way to now improve our technical communications. This is a course taught by Steve Kinney, head front-end engineer at Temporal, this open source tool, a durable execution platform that covers specific business use cases like Kubernetes, right? So you can think of this like a specific Kubernetes that covers a specific business use case. So actually that's a very interesting tool, and the goal of this course is to see how can we now write performant React components, therefore React application. And for that, we need to understand that how this thing works. So anytime you want to improve something or to fix the performance of something, you need to understand how that thing works. Whether it is on the arts, fitness, nutrition, in your profession, your communication skills, and right now is on this technical skill. So I'm going to make a quick recap of what we have learned so far in this course, which is introduction and the React rendering, by looking at the React doc.dev here. Briefly describe is the learn sections like this. So describing the UI, adding interactivity, managing a state, and then finally we jump on to the escape hatches. So the idea of doing this is as a way to improve the storytelling learning process and explanation. Why is that? Because we as humans, and this is something that is my personal approach and based on my own experience, we make sense of the world through stories. So you can ask to any race, color, religion, and most of the times those people learn that from their elders, and that's how they make sense of this world. Sometimes that narrative actually are not aligned to the nature, like some conflicts. And even though that go beyond perhaps the scope of this course, but the world is not your fault that the world is what it is, but it's your responsibility to get it. So here we are, describing is briefly here this introduction. Well, the value proposition of performance in React is that since React is all about to rendering UI components or describing UI and rendering it, okay, something that we're going to talk about that later, it also is, for this course, is faster not doing stuff right now than later. And there's some corollaries to that. It is much more faster doing things later than doing it right now. So the idea here is that when we are able to understand how React works, we can now identify some of these performance issues, develop some tool sets, and then we come up with some solutions, aka best practice, as a way to solve this. So that's quite interesting. And Steve Kinney mentioned briefly something that we're also going to take a look at the end of this course. Hey, we would like to actually describe this tool set that we're going to build. And that is, first, identify is the live site is using the production flag. Also, take a look now at the component hierarchy and your state, and then start from there. Take a look at what are the rendering or the catching mechanism or the catching strategy that those who build the app now implement. So as a way to actually see if you have any performance bottleneck down there here. And the other is that see how now these applications are loading lazily, okay, using the suspend API. And if you're in a really pickle, use the transition API, which is now something that React allows you to do. So as a way to now defer rendering or have this notion of high priority and low priority rendering. So on that topic, okay, we need to understand is what React it is, okay? Look at the tools that React offers us, like the React Dev. So with the components and the provider tab on your browser. So the component is for dev, the provider for performance, and we need to know actually what is all of this, what is all about this on the React. So by looking at the top, React, after all, is a JavaScript framework that allow us is to describe UI. How can we do that? By using its JavaScript function. So these JavaScript functions, we look at how can we import or export, aka these components, okay? And we also see how can is use the GSX markup language as a way to now see how we can have is JavaScript in our HTML, GSX, as what they call it, okay? And also how can we now interact with our HTML using, or how can we interact is the JavaScript world with the HTML through event handlers using the curly braces. How can we now pass data to these components as props? After all, these props, they are read only, so you shouldn't mutate that. Also, we look at how can we conditionally render components. How can we render a list of elements? And for that, now how can we now React demand us to put is a key when you're rendering that element as a way for React to keep track of that element. This is pretty much like you have a folder with all of these different files. So if you know this, so if you're sure of what you have there in these folders, so you know what's going on, you can do some things about it. In the case of React, it's like, hey, someone took out this, someone took off this element or this file from my folder. Okay, so let me now organize that. So the idea of this is that look at this basic component. What are the basic the basic anatomy of the React components, as well as understand why it is important to write these components in a pure way. So the reason for that is because it allows to run this function or these components in any JavaScript environment, for example, in the server, where we can now run this component, given the same input, we can now serve this component to hundreds or thousands of users. The other is it allows us to identify it allows to catch some components, okay? So, for example, using catching mechanism like use callbacks, use memo as a way to save us computational time and therefore costs, server maintaining costs. The other is when you're passing down data in your render tree, you can now safely stop the computations and do that again. So this is something important to understand as a way to, well, now that we describe that briefly, okay, and what this this purity in this component means is that given the same input, you will always get the same outputs. And side effects are known as this unintended consequence. So the idea here is to have much more certainty of what's going on in these components. And every time we call them, we now, given the same input, we always get the same output. As well as how is the thing called render tree, which is the way of how React now sees your component. It also uses this data structure called tree, which a data structure is just a way of how can we organize all of our data to cover a specific use case that is helping us is for a specific thing. So for example, a fridge and a backpack is a very useful storage. Therefore, a very useful way to organize your data. Data like what? Well, in your fridge you can put is ice cream, you can put fish. In your backpack you can put is your tablet, keyboard, mouse, iPad, you name it. If you swap the order, again, you can get what you want, but not with the same outcome that you desire. So you can put fish in your backpack, and then you got a smelly, and you will be someone to avoid. Anytime you get close someone, all right? Or you can put your Mac on your fridge, and the battery life will be expand, but the battery duration it will be short. And this is well because how now this battery actually works. And it's quite interesting, by the way. So the lower the temperature, the less life battery durability you will have, but the longer the lifespans of this battery have or extend. It's quite interesting that physical aspect of the battery in any case. So that's why we have this specific data structure. So common data structures are array, collections of elements with an index. We also have hash, which is pretty much like a table. What you have is now a key and a map, okay? Or dictionaries, as they call it in Python, all right? So you have your key, and you have the description or the value, okay? Also we have is stack, queues, tries, linked lists, double linked lists, trees, and graph. For our particular case, the software developers on Facebook decide to use a tree as a way to represent this. And when it comes to actually now render things or calling these functions to repaint, to redraw that, it is the best way to actually do that. In any case, something that we're going to talk about that. But this is the render tree. So once you understand that, how that works, you're able to know how the data go through this, as well as be able to identify is any performance issue. And also we have is the tree dependency or the models dependency, which is our files that we add to JavaScript file that we add, or CSS files that we add to each one of these components to provide them some more functionality or interactivity to that. So doing that, the idea here is that you want to make your tree dependency as fit as possible, you know, in a way that you only send the necessary data followed by the components to the browser. So once we look at this, which is describing the UI, and then we now look at we also mention, or I mentioned something called that the rendering, okay? which is now how can we add an interactivity to our React components. So first, we do that through the event handlers, okay? And as a way to preserve the state, or as a way to show something to these components, okay? Some data, pretty much like you entering in your, let's say, Stripe or any bank account in your app, and you now can see is the balance, as well as the transaction history, and all that kind of thing. So the idea here is that when you're able to do that, you may wonder how you can now show this data and then preserve that data there. So that's why we have state, which is a components memory model. Behind the scene is using something called closure. I don't want to dive deep to that because this is a React course, okay, this React description. But closure is this nice little bonus features that allow us to remember persistent, that allows to remember persistently, okay, or that allow to remember persistently, or remember, I prefer to use remember, that allows to remember persistency, data that is outside of its scope, and that's something important because this closure things enable is patterns like memorizations. Hey, I just want you to run this function once. And if you receive the same, given the same input, if you haven't calculated that, compute that, store this value, and return it. However, if you already now is, if you already previously calculate that input, so instead of compute that, spending time of that, return that. Because the most important asset as a software developer is their time. So, all right. In any case, because we are now make use of this state using this hook from useState, we can now is preserve this state or the data in our components. So if we want to update our state, we use a setter function for that, that provide us for that React provides for us. And the idea of that is that when we set our states, React pass through a rendering mechanism. Render, this concept that I mentioned before. And that mechanism, pretty much like an assembly line, okay, it say, hey, you're going to pass through this series of stages: the trigger, the render, and the commit phase. So once, for example, React trigger and a state update, which is can be at the root element. Remember, we are talking about the render tree. Okay, if this happened at the root element of the tree, or if this was caused by a component or any of these components whose state or that update the state, so React detect that, then go to the next phase, which is rendering. Therefore, it say, okay, let me know when this happened. If this happened at the root element, let me create all of these elements using the create element DOM API. If this happened during a re-render, so React will call that component that trigger that state update. It will compute that function with all of its properties, event handlers, and state. You're gonna hold a reference of that, and then the output, which is a GSX element running that function or calling that function, if this contains React components, it will call those components, and if the output of those components contains more React components, it will do that in a recursive way until there is no more nodes, React components. So once he knows that, okay, the next phase is the commit phase, which say, hey, if this happened at the root element, Now it is time for me to append all of these elements and show the UI to the user. But if this was caused by a re-render, okay, React now will commit those states with the previous information computer calculated in rendering, and if there are differences between renderings, therefore React components, now React will going to apply the necessary DOM updates to that. You might wonder how React know this thing, how React actually know is this different, how he can barely able to actually look at two things and compare that. What's going on behind the scenes? So, because there is a concept in programming, this is not a technology, it's a programming concept that is being used by several JavaScript libraries, for example, like Vue and React, okay? Where they say, okay, we want this to hold a virtual representation of the DOM in memory, okay? And we want to keep sync with the real DOM. The point of this is that once you know this virtual representation of the DOM, so React now is able to compare that the previous virtual DOM with the new DOM, which is actually calculating all of this rendering or calling all of these React components. And if they're different between this virtual DOM representation, now React know what changes need to apply. So through the diffing algorithm, now React, so through the diffing algorithm, as well as the React Fiber, which is now this reconciliation engine that comes with React 16, which makes this reconciliation process much more effective and efficient. Okay, now React know what are the necessary changes that it need to apply to the DOM, okay, and then sync with the DOM. And that's quite interesting. And there's a lot of things going on, especially with the fiber mechanism, okay? Something that I can briefly describe that, for example. Let me get in here to my GitHub account and say, hey, what the F is this? Okay, chill. It's like this, exactly. So for example, when we talk about the virtual DOM and the internals, mentioning about is this virtual DOM. And React, however, also use internal object called fibers to hold additional information about the components tree. So this is quite interesting because now they have is the virtual DOM, and React particularly is a special inner object called fiber that hold additional information about the component tree, which makes now the reconciliation phase, which is the commit phase, much more performance. There's several concepts there when they describe here, for example, of course, none of these components actually works, that kind of thing. It's like none of this actually works. React basic theoretical concept, like this. It's only this. This document is my attempt to formally explain my mental model of React. The intention is to describe this in a term of deductive reasoning and lead us to design. So this is now the transformation here, font weight bold, and label content, like this. So this is several concepts. I like to have a simple mental model that I can ground myself. Transformations, abstractions, composition, It's interesting because when you return this object here, and when you call this, which is a function, it's going to create now a closure that will make you allowed to access to this. A memoization, for example. This is a very interesting thing because now this is how React keep track of your state. Okay, calling the same function over and over again is a wasteful. If we don't know that function is pure, we can create a memoized versions of function that keep tracks of the last argument and last result. That way we don't have to re-execute it if we keep using the same value. Exactly. Memoization, lists, continuations, state map, children, state map and update state, fancy box user list, and I think the using is memoize. Okay. As you can see here, that's right. They actually is now fancy box, but here now they actually is calling is a function here. They're returning is a function, which is creating effectively a closure for that. A closure that this function will have now the children's, the state map, and the update state. Memoization map. Okay, as a way to prevent is this function to be called given the same input, as a way to prevent a functions to be called several times. This as a way to prevent the, as a way to save, as a way to not compute a function or not to run a function given the same input over and over and over. You just calculate us only one. That's a very interesting concept of the memoization, because it comes from this AI research called Donald, not Trump, Donald Michi, that actually come up with this particular concept. In any case, yeah, but this is now the commit phase. Okay. So when that happened, so when now React, by using the virtual DOM, this technique as a way to hold the ideal representation of the UI DOM that sync to the real DOM, and when it render, it means when it call all of this React component as a way to create it is this new version of the virtual DOM, and through the reconciliation phase, which is using the diffing algorithm with the fiber, which is now is an internal object that represents some additional information about the render tree. Okay, now it can apply those changes, okay, and enable this incremental rendering or this performance optimization here. And also React Fiber, which is this reconciliation engines, it provides us is way of how can we I think way what is reconciliation? Is the algorithm React used to diff one tree with another to determine which part needed to be changed. Reconciliation versus rendering. Scheduling, and what is a fiber? So with fibers, React component as functions of data. Structure of fiber, type key, child, and sibling. But again, this is what I'll allow fiber. Password and come back it later. Assign priority to different types of work. Reuse previous completed work and abort work if no longer needed. This is the very specific things that we can do. So for example, assigning priority to different type of work, this high priority and low priority rendering, okay? and that's good. That's actually quite interesting, by the way. So once we did that, okay, yeah, yeah. So once we know what React is doing when it applied this, so now that we know what happened during the commit phase, which is applying these elements here, using the virtual DOM, and when it when in the render phase actually create this new virtual DOM representation with the new update stated, when he applied the reconciliation phase using the diffing algorithm or any other reconciliation algorithm that might using behind the scenes, now is able to apply is the necessary DOM updates and keep it synced with the DOM. So now the DOM detect those changes and paints your application. I think this is a beautiful process. It's also something that actually took time and energy for a lot of people behind the scenes. And again, I am here because of this giant shoulder. I have access to the internet, I have access to this Mac, which is a very powerful computer. I also have access to now this knowledge. I also be able to create this thing here. Even I improve my communicational and technical communication and my soft skill as well. This is beautiful, wonderful, all right? So in any case, this is us describing is this rendering mechanism in fine-grained detail. So every time you actually now set the state, you know what's going on behind the scenes, okay? So, and when you set the state, because after all you define that pretty much like a variable, they don't behave like a variable. In fact, they persist after the React render that component, call that component. So when you set the state, you can think of them as a snapshot per component or as a snapshot per rendering, okay? So this is when we look at, you're going to set your state inside of your event handler. You're going to, if you want to get the next, so the state value change is in the next render, okay? And when you are working with the state inside of your event handler, you can think that React fix that state within the current event handlers. So this is a way of how you can think now of our state in contrast with variables in JavaScript, okay? And how this, what are the things that it now enables to do that? So for example, is this batching or this sequence of orders or state updates that we can tell to our waitress, React. So we can do that. And the other some less fairly common, but actually useful as a way to pass now is a function that during that rendering you want to, during that event handler you want to trigger several state updates, wait for something to complete, an async operations, let's say a timer, an animation, anything that a promise or anything that takes a long time to complete, okay? And a promise is this concept in JavaScript that represents is the eventual completion of a task that will take long time to complete or that will be completed sometimes in the future, async work. So then you want is to look at how you can keep up the state updated after that async operation. That's quite interesting, by the way. Totally. Because remember, after all, states are state is, so our state live, as I mentioned here, uh, state variable never change is like now, but during here states exactly. It's because JavaScript is using that states at the rendering time. Okay, so React is using that state at rendering time. So then I look at how can we now update object in the states. How to update object in the state, array in the state. The TLDR of this is that always return is a new state out of that. In the case of objects, avoid any mutations or avoid any deeply nested objects. And when we talk about nested, it's an incorrect term because those are new objects that points to a particular property. So the whole point of this is that by returning as a new state on objects or in an array, we can prevent some of this issue that object-oriented programming actually hold, for example, with or when building these applications. So that's why Solid Principles kicks in, which is a book that come up with some principle here as a way to say, hey, anytime you are building your applications using an object-oriented, anytime you're building an application following is the object-oriented paradigm, it is important to make this object single responsibility, open to extension, close to modification. So if you want to create a new object that contains or that reuse some of this previous work, you can now by subclassing, by creating an object that points to that, you need to make that object capable of replace of this class that is inheriting its property that I having access to, which is known as the list of substitutions. And if you now want to define more and more properties and method to this, it is useful to define is interface as a way to, instead of throwing that an object to your face, okay, pretty much like if you have an oven, all right. So instead of actually you having to manually, instead of the manufacturer giving you this oven, where instead of giving you this knobs, it give you is the gas connection or the electric connections, so you can actually see and doing by hand that connections. So instead of actually doing that, exposes an interface for that. So this is known as the interface segregation, followed by the dependency inversion, which is low-level models or high-level models should not import low-level models. So rely is on abstractions, not on concrete. A good example of this is the same with the oven, with the stove. So you have your stove. So instead of actually you having to an electric stove, instead of having you know which cable do you need to connect as a way to one of those stuff works, okay? You don't want to do that, okay? First, it's not easy to work. It's not easy to handle that. And second, wouldn't it be better to create is an abstraction, and that is a knob, okay? Where we can now actually is interact with that. I don't know what's going on. I don't care what's going on. how that things actually works, but I just want, when I turn up the knob, the magic happens. That's all. So again, this is just providing is some of these concepts. And when you're building is this application using object-oriented programming. And now object-oriented programming is just a way of how you can organize your style. What in the F is this, man? As a way of how you can organize your data and functionality into the same bundles. Why is that? Because, well, previously people on the 60, they have a trouble, they have a pain in their ass with now organize all of this data and that kind of thing. So they come up with this alternative as a way to group that data and so on. Again, this is not a course of object-oriented programming. I just briefly mentioned that. So now that we know how can we update objects in a state, return is always a pure object using the spread operator, as well as the returning a new state with arrays. Okay, so for example, hey, I want to add an element to this. You're going to return is an array when you're going to indicate at which position you want to add that element, whether it is at the beginning or the end, using the spread operator in between. This is adding an element. If I want to remove an element, I want you to now filter that, identify that element, and return. So whatever filter return, which is a new subset of the array without that element. Okay, so that's it. For example, like this, so filter that. Okay, so I want you to give me is this new array. So I delete that. Okay, and the other is, well, I want you to perform some transformations to an array. Use map for that. Okay, and the other is replacing items in an array. You can use the other is replacing items in an array. So iterate through that array, satisfy the conditions, and apply the necessary data to that, and always make sure that to return is a new state. So the idea of this, and when you want to make your update logic consist, okay, is by using IMER. So you now have this mutable syntax to actually mutate your state. So far so good, because now that we know how can we describe our UI, how can we add interactivity to this, how can we now scale our applications? In other words, how can we now make sure that when we are building more and more UI elements, how can we make sure that we're managing all of our states, okay? As well as how can we make the state update logic maintainable? And furthermore, how can we now pass data in a way that is scalable and maintainable? So that's why Reacts say when you're defining your state or react to input, okay, it is important to think the React way, which is how to think about UI change as a state. So when you're going to describe your UI, it's important to follow the same approach, similar approach of the UI designers when they define all of these wireframe and all of the visual possible state, and combine that with the compute state finite This is state finite machines, okay, that allows you to represent is the different visual states, and also the trigger that actually made that possible to go through one state to another. I'm gonna use the same example of the oven, okay? So That's what you have is this nice little graph here. We say, hey, if the knob is in this position with the arrow pointing down, it's off. If you move that, hey, it's open, right? If you move that up, it's open. So this is now how you can represent those UI as a state change. So because the idea here is that instead of doing that in an imperative way, when you can say document get element by ID, and then once you get these elements, I want you to now apply something based on an event handler. Okay, for example, when you have a password, you have the input, you have the button, and when you click on the button as a way to show the password text, okay, you can do this in an imperative way, but the value proposition of React is say, well, instead of actually doing that, which is pretty much like you're getting into a taxi cab, okay, yeah, which is pretty much when you're getting into a taxi cab like that, you tell the driver where they need to turn, you know, instead of actually telling where you want to go, and let them figuring out what is the best route to take them. Okay, so this is now the declarative approach, and this is declarative because most of the time we're going to handle is large collection of UI. Okay, and with this declarative approach, we can now delegate that lower things that we need to do to the framework, to React, and we can focus is on what is relevant for us, building the UI. So this declarative approach say, okay, first identify all the different visual states, okay, all the different visual states, then determine what trigger those state change, okay, on click, on typing, network requests, and on request next frame, on request animation, determine what trigger those at, and then represent the state in memory using, represent those states using the use states in memory, okay? So avoid or eliminate any non-essential states. And how you can do that? Well, any state that, or any data, or any information that doesn't frequently change, that's not on a state. If you can get your state from other data, that's not on a state. What left probably might be in a state. And I think this is connecting the dots here, which is thinking in React when they describe is this. So this remain unchanged over time. Exactly. Does it change? Exactly. Does this information change or doesn't exactly? Doesn't remain unchanged over time? That's not on the state. Is this passed via props? That's not on the state. Can you compute that information from the state or props? Definitely is not on the state. Okay, and I think this particular mental model is something useful when you need to actually tackle this particular problems, especially when you're going to define or you're going to react to input state. Okay, as a way to describe your UI, adding interactivity, and create more and more UI elements. So last but not least, then you connect the handlers to set this state. But this particular topic here, as they mention here, right, to me is quite interesting and quite compelling, because now this at least gives us a sense of when we need to create our component, okay? And when we need to represent those states in memory using a state, and ask ourselves, hey, is this data remains on is this data remains unchanged over time? That's not a state. Is this data comes from its props? That's not a state. Can we compute or calculate? Exactly. Can we compute this based on its props and states? That's definitely not a state. What's left probably is a state, and I think interesting because they start with the don'ts. I will make a quick pause here because one of the things that you can find out in how to live your life, I'm going to put it more philosophical and then I'm going to be more practical. Bear with me. It'll be quickly. So one of the things that you can figuring out in your life quickly is that those things that you don't like. I think it's way much more easy to detect that and then act upon that. That's my tech talk. All right. So yeah. So yeah. Absolutely. So with that, okay. When you are going to react to inputs, especially when you're going to determine or to represent those state as those state using the user state, is that hey, does this information remain unchanged over time? That's not on a state. Another way to paraphrase that is like, hey, is this data doesn't change? Okay, or does this data remains unchanged over time? That's not on a state. Is this data come from our props or exactly? Is this data come from our props or from the from a props or from an state? Or is this data come from a state, from a props? Jesus, that's not a state. Can we compute this data based on its prop or state in that component? That's definitely not a state. So in any case, so that's now how you can connect things, okay? And then move on to how can we now, so first here we look at thinking, how to think in, yeah, that's right. So how to think about UI change as a state change. And then we look at then how can we organize our state, okay, as a way to make it much more easy to maintain with less or bug free as much as possible. So once you structure your state well by following this principle that they borrow from database engineers, when you have now is the concept of normalization. So now it is time to say, all right, good, because React gives us this principle, and they say, all right, when you're going to organize your state, group related state together, avoid any contradictory states, avoid any redundant states. Hey, can I get this information from its prop or from another state in that component? Avoid any duplicate state because it make it hard to sync, and avoid any deeply nested objects there because now it'll make quite hard to update those states, as well as because now you're working with reference there. So in other words, make those state plain as much as make those objects state plain or on one level. And then we look at now how can another common thing, which is known as state lifting up, or how to lifting a state up, which is how you can share is a state across different components, how it is useful to think in terms of uncontrolled and controlled components as a way to say, hey, this particular object or this particular component that it will have is, this particular component that it will have is, this particular React component that I will hold this state and I will share that across all different components. It is good to think in terms of uncontrolled or controlled component. In other words, when you're writing your components, is this data managed via these props? Then it'll be, this component will be controlled component by someone else. And is this component will act as a configuration, meaning that you need to define is this state in your component. So this is known as uncontrolled component. The entire reason of doing this, okay, is that when you have a component that share as that state to several other components, you are responsible for which components owns that state, aka that component is the source of truth of all other components. So if any of these ancestor components, any of these descending components actually update that state, all of those other components in the subtree will now apply, or will now receive those state updates. So that can be quite problematic sometimes, or not. But the idea here is that this is not the concept that, for example, Redux stands upon. That is that instead of if you imagine now a render tree here, okay, if you imagine a render tree, so is that sub level down there, and I think this is quite abstract, but bear with me. If you are able to imagine a render tree, and if in a particular node that contains more children components, aka a subtree, if you define a state here, if you define another state here, if those state needs to share, okay, so you can lift them up to the parent components, okay, and what happens is that now all of the subtree elements will going to use that shared state. So as a way to make your application much more easy to maintain, okay, we look now those states by centralize that states into one single file. We can now pass those states across all of the relevant components that it needs to, making our life much more easy to manage, and understand along the way that the state is tied to the position of the render tree. So if you want to reset the state of, for example, if you want to resetting or preserve the state, React has a particular way, or has some condition here, some rules here. So components in the same component at the same render UI tree position will now preserve the state. Different components at the same position will now reset the state. And if you want to reset the state of this from the same, if you want to reset the state from the same component at the same position, you can or render the component in the different UI tree. And again, states are tied to the UI position, not the GSX position. Then the other alternative is to use a key as a way to say, hey, I want you to now keep track of keep track of these components, as a way to when I show all of this in the same position, hey, I want you to now reset the state for me. This is something that might be useful, for example, if you want to now render elements like, for example, if you have a list of elements there, then you want to render now components and the initial state. So for example, anytime you choose a catalog, okay, you reset the state. That'll be something that you want to. Or if you want to preserve the state, you don't use a key for that, okay? Again, this is just to cover a specific business use case. And when it comes now to manage our state update logic in a maintainable way, we use this thing called Reducer, which is just a fancy saying. This is a fancy name to say, hey, this is a function that takes an state and an options and generate a new bit of a state. So now this is passed to the React to set the state for us, okay? And by running this Reducer functions, we can now have much more control of which UI state we want to. You may wonder when we need to use this. The more input that this state needs to react. So for example, click, type in, so for example, click or on input, on hover or mouse over, the more inputs, whether it's computer or human inputs, okay, computers are, well, rendering an image or performing a network request or receiving data from the server. In human computers, it's like, for example, typing or navigating to a different route in the browser. So the more input that this state needs to react or handle, the more likely and it'll make more sense to use is the reducers. Okay, we also look at how can we use our reducers, how can we define that, the reducer function, how can we make use of that using the use reducer, and by using is the dispatch, we're gonna pass this now a specific object followed by the type of the name of that action. And this is something now Redux allows to do that programmatically. Okay, so instead of actually you passing a string for that, so Redux say, hey, let's go to now export all of these actions so you can make use, and now the ID can automatically provide you some hints. Thanks for that. And on that line, once we look at that, all right, and when we want to now pass data down to different components, okay, how useful is for us to use context? Again, the problem that solves context, pretty much the problem that solves Reducer is that for Reducer, hey, how can we make our state update logic consist, maintainable? And with context is that, hey, how can we pass data to distinct components in an organized way, okay? Or in a centralized place. So this is now, the problem that is solved is known as props drilling, because as you pass down data through all of these nodes in your tree, if one of them is removed, for example, you show them and then you hide them, giving a specific logic that you have in your render tree, all right, it's gone. So what are you gonna do? You know, so you break the data link change. You break the data link. So context came here and say, all right, React provide this as a way to store now is this context, okay, this data that you want to share across different components, and also this is state, which is something that we're going to find that when we use is with reducer, which is a fairly common practice here to combine its context with state and reducer. Okay, so we look at that. How can we now create our context? Using the create context, and then we pass some data to that or some state, okay? And then we're going to now use that context using the use context hook from React, and use that context hooks from React, okay? And now provide that data one level above the component that is being used. At least we need to put that. We can also define is the consumer and the context at the same root, okay, or at the same level. And when it comes to not overuse context, because contexts are very useful for small tiny things. So for example, theming. So for example, authentication. You have the user login. Okay, and when the user log out, when a new user log in, you now share that data across all of this render tree or the tree components. And also, it is useful, for example, in libraries like React Router, which is actually make use of context. If you take a look at the library, actually you see a section that is using context. And also, and also, we can use now context with reducer as a way to organize our state update logic in one single place. It might be tempting to overuse it. The problem with context is that since React will render components, since React will render children's that consume the context starting from the provider, when you update the value, if any of those state doesn't need that context or right now at that moment, okay? And this is something interesting to know with the use state. Anytime a component, because it's that, it's like React use context. Because it's that caveat. Use context call in a component is not affected by providers returned from the same components. The corresponding context provider needs to be above the component doing the use context call. React automatically re-renders all the children that use a particular context starting from the providers. You know, React automatically re-renders all the children that use a particular context starting from the provider that receive a different value. If that value changes in the provider, all of those components that use that context, React will re-render. So if a component doesn't need that, okay, or is not relevant for that, it will actually call that, causing is performance issues. So skipping re-renderings with Mimo does not prevent the children to receive fresh context value. And if you're building a system, if your build system produces duplicate model in the output, which can happen with symlink, this can break context. But I think one of the relevant thing of this is that React automatically re-render a component, or React automatically re-render all the children that use a particular context, starting from the providers, that state changed or that value changed. So if those components don't need to update that data at that moment, it doesn't care. React will gonna call the components and re-render that. In other words, it's gonna call that component, calculate the props, event handlers, and states, the return of that component, which is a GSX element. If that contains more if that contains more React components, it will call them and repeat that process in a recursive way until there is no more components. So what happens is that you're causing is cascade effects anytime that use context, anytime that a component use context in which value, in which the provider value change. For example, you might want to have the theme, which is good, okay? Again, this is one thing that can happen, one input that can happen. So the whole point of using here context is for a small piece of data that rarely change. Again, for a small piece of data, I will say that. For a small piece of data, whether it's that data is changed regularly or not, but as long as they don't impact the performance of your application. So a good example of this is that you can use the context, the provider, as a way to, or the use context as a way to repaint something. But instead of using context, it is better to use an state and trigger an event. So, you know what I mean? So the TLDR of that context is that, yes, contexts are useful for a particular case. Small app level data, using with Reducer as a way to make your state update logic maintainable, okay? And you can now scale your applications and scale your state and scale your UI. But when it comes now to like this, okay? But when it comes now to actually look at these escape hatches, or therefore is things that sometimes now React need to, again, sometimes React need to, how do you put it, control or sync with outside React components, okay? So sometimes now React components needs to control or sync with external system. And I think this is a very interesting topic here as a way to do this. It's like, because here we are. And I really love that description. I really love this description because it was like oh my God. It clarified a lot of the things, totally. So anytime we're now getting into, or anytime we are writing on components, we know what's going on behind the scene. And I think this is, oh my God. You need to know the mechanism. That's all I'm going to say. Again, it's not your fault that the word is what it is, but it's your responsibility to get it. If you're going to provide these JavaScript servers, it is important for you to know how that things work. Find some mentors, pay for them, make that learning systematic as a way to know you can replicate that. So in any case, Yeah, that's quite interesting. That's quite interesting, especially when you put that at practice. So here we are. Looking at now, when you're writing your React components, sometimes you want to have control and sync with external systems. So for example, focus an input element using the browser API, or play and pause a video player implemented without React. Okay? Or perhaps you want to connect and listen to message from a remote server. So to do this, in this chapter, you learn the escape hatches that let you step outside. Step outside. Step outside. To get out. Step outside. Step outside. Step outside. Interesting. Step outside. To get out. Oh, nope. To get out. Exactly. Step out. This is British, man. This is British. To get out. Okay, to step outside. And I get it why a lot of people actually use get out. Step outside is way too long. It's like no, man, get out. Quick, concise, direct. That's right. I like it. Step outside. Okay, so here we're gonna learn is the things that let you step outside React and connect to external systems. So most of your application logic and data flow should not rely on this feature. Remember that after all, React is all about describing UI, adding interactivity, managing states, and rendering. The whole point of React is that you get a state that you want to generate a view out of this, which is describing exactly this React to input. Okay, that's the mental model of React. Now you get it. Oh my. Oh my. Oh my. Oh my. Oh my. Oh nigga. Exactly is that. React to inputs with state. You got a state that you want to generate a view out of this. Is a way of how you can simplify this. Okay. You got a state that you want to generate a view out of this. And you define all of these different state updates using handlers. To manage your handlers, with the more it is scale, the more it becomes to manage your. So the more input you need to React, the more inputs with this computer or human this state needs to update, the more sense it'll make to use is the reducer as a way to managing is the state update logic as a way to keep the state logic maintainable. Okay. And here we're looking is that how to remember informations without re-rendering. Okay, how to access DOM elements managed by React, how to synchronize component with external system using the use effect, how to remove unnecessary effects from your components, how an effect life cycles is different from a component. Interesting. How an effect life cycle is different from a component, how to prevent some values from retriggering effects, how to make your effect rerun less often, how to share logic between components, which is known as custom hooks. And with that, that's all. Yep, that's all. Okay. Use state, use counter, use effect. But for tracking. Okay. So we looked at, this is a specific use case here, with escape hatches, or sometimes here we're gonna learn is how to step outside, or to step outside of React, or to get out of React, okay, as a way to remember this verb, as a way to control and sync with external systems. So first we look at how React remembers things without re-rendering, and that is using the useRef. Okay, so useRef is like the secret pockets where now React doesn't keep track. Okay, but what you can store is data here. When you can and when you want to use this, you may wonder, well, for example, when storing timeout ID, and I make this example here as a way to do that, like this. So when you want to store timeout ID, and then you say, hey, I want you to now make use of this. Why? Say const, say timeout ID. Okay. Say useRef. We need to import that. Okay, that's right. And I love this because it's now make our code much more declarative. So we have now the intended code here. Yes. So useRef here is null. So when can we use this secret or when can we use this? Yeah, secret pockets where we can remember things without re-renderings. Okay, without trigger re-renderings. Okay, the component doesn't re-render with every increment. So using now the useRef, okay, which is the way of how you can, which is a hook, okay, where now React doesn't keep track of this as a way to re-render components. So anytime you update the useRef, which you can do that in a mutable way, in the way of how you can update that is that now useRef provide you a current property where you can now read and write from that, mutate. So you say timeout ID dot current, it'll be that. Okay. And when you want to define now is a button here, another button here, say button here on click, then you say is handle stop, handle stop. Okay. So now handle stop, what it's going to do is, hey, this is the function to handle stop, and I'm going to do is this. I just want to clear the interval of the timeout id.current. So you can start that, and then you stop it, and you start again, and you stop it. Okay, the idea here is to do that. My question is that how can you now make, for example, this seconds to happen? You know, you can start this, but now set now this is the date now, right? So we can is in this particular case, because we define as a start time, we are defining as a stopwatch. Okay, create here is a stopwatch. Interesting. Start time and now. And then we can say something like this. It's like now. Second pass is to fix 3. Why not use this? Oh, because it contains date now. Okay, no. Okay, I get it now. Exactly. We had the date that is now and the current. Defining is the UI as different state. Okay. So is this data is going to change over time? Maybe a likely candidate here. So start time and now. Why the start time and now. So what it's doing here is that, hey, I'm going to now start this. Okay, in every 10 milliseconds, I want to now set the now. Set the now. So if I want to now do this, and it is interesting because when I click here, I'm gonna trigger is this over and no. So I'm setting this state for that, which is enabling is. Let me actually do this, because here we define is the stopwatch, and I think this is something interesting because most of the time it's like you don't know what's going on. So let me do this. So here we define is this. So we define our start time, set start time. Okay. Start time, set start time, using an state here. All right, which will be null. So this is the start time that we're gonna get at the beginning. So when we react to this input, we want this to set that state, okay? And then count that, which means that let's go into define is it's gonna show, it's gonna count the current date now and set now again as a use state. We define this because this is information that is going to change over and over. So does this information remains unchanged? No, they don't. Can you get this information from its prop or any other state? No. Can you get this information from other sources? No. So this is likely to have a state here. Okay. So you got the start time, you got the set time now, and the set now. Because the idea here is that we are using is with the timeout ID, which is a special use case here of using now React to create a stopwatch. Okay. Here we define is also again group related state together, and here's when I'm going to now define is the useRef, because we're gonna use a timer or a timeout ID. I'm going to now is to define is the handle star, okay, as a way to say, hey, let me now is when you click here, click star, handle star, when you click here, let me now set the state, okay. When you click here, now let me set the state here, and that is set now. So set start time with date dot now, which is right now. We want to actually take a look at the date object here, because this date object is quite cumbersome. The epochs, timestamps, and invalidate. So JavaScript dates object represent a single moment in time in a platform-independent format. Date object encapsulates an integral number that represents milliseconds since the midnight at the beginning of January 1, 1970 UTC. That's quite interesting. TC33 is working on temporal, a new date-time API. Read more about it on iGallia blog. It is not yet ready for use. There has been long-standing pain points in ECMAScript. This is a proposal for temporal, a global object that acts on top levels namespace like math that bring a model date API to the ECMAScript language. For a detailed look at some of the problems with date and the motivation for temporal, fixing JavaScript dates. Temporal fixes this problem by providing an easy-to-use API for day and time computations. First class support for all time zones, including DST safe arithmetic, dealing only with objects representing fixed date and times, parsing a strict specified string format, supporting non-Gregorian Temporal provides separate ECMAScript classes for date only, time only, and other scope use cases. Temporal.now instance. Temporal zone date time. But this is a proposal. Exact time types in plain date times. String persisting, parsing, and formatting. Yes, okay, part of the standard here. In UK Japanese. This stage 3 proposal is experimental. Do try it and report bugs and use it in production. Okay. Fixing JavaScript dates, getting started. No support for time zones other than the user's local time and UTC. Parser behavior is so unreliable it is unusable. The object is mutable. DST behavior is unpredictable. Computation APIs are unwell. No support for non-Gregorian calendars. Web reality and web compatibility. This was in 2017. Jeez. This was in 2017. Yeah. Enterprise software developers. I am the enterprise software developers. I translate business requirement to code. I then proud of it. I add value to the community. It keeps the cloud running. And all of this. This is what in 2017. What? What is this person? Maggie's blog. There's a lot of weird person here. It's a lot of weird person here. It's a lot of weird person. Anyway. Anyway, so this is a proposal. Anyway, good. But after all, this is date. The epoch timestamp is invalid, and here's when you can access to this static methods. You know, not the instance method. When you create that, is this static method. Okay, static method. Anyway, here we go. Date.now and date.now, part of the static methods. And then every 10 milliseconds, I want you to now set the state here as a way to notify React, hey, there was a state update, pass through the rendering phase. So trigger render commit, the browser paints. Trigger render commit, the browser paints. So trigger, it was here at these components. Render, it is calling these components and calculating it as the states and event handlers, props. Okay. Commit, it is now say, okay, now that I'm using this virtual DOM representation and I get a new version of the virtual DOM, I'm going to compare that or reconciliate that using the diffing algorithm as a way to now apply only the necessary DOM updates by doing this reconciliation to the virtual DOM that we keep sync with the real DOM. And when the real DOM detect that, now it'll paint that. And because we're sending is this renderings every 10 milliseconds, it will now React render all of these elements like that. Okay, so set timeout. We're gonna use this timer browser API, okay, where behind the scenes is using the callback queue. So the callback queue is now the place or when now JavaScript engines add all of these tasks that will take some time to complete. In the future, in this case, the web browser, because this is now not relevant to JavaScript, is relevant to the JavaScript environment, which is the browser, in this case, that it say, hey, I'm going to execute this function when that time has passed, pass through the callback queue, where now, thanks to the event loop, it will notify if the call stack is empty, so meaning there is no any other elements evaluating here, okay? If it is, all right, pass that to the call stack, JavaScript detect that, evaluate it, and boom, that's all. Which is here. So we're gonna pass this arrow function here, where I want you to evaluate every 10 milliseconds and say, hey, JavaScript, I want you to now run this function. I want you to now update the state here. Set now with that date.now. You might wonder, when JavaScript now runs this You might wonder, where is set now? Because, yeah, this is a function, right? But does this function, when you run that, it pop up from the call stack? So there's nothing to evaluate that, okay? So what is this? How now JavaScript know that this is a function? How does JavaScript remember this function and need to run this? Oh, because after all, this is a closure. So now React have access to that. So now in React, so JavaScript have access to that and know what to do with this. It contains all the instructions needed to update the state. Powerful, powerful. But the thing is that because now we're setting is a new timeout every time here, and we want is to clear that interval, okay? We can say something like this. So anytime we rerun this star, we want to assign this to the timeout ID, okay, to the current property, which is this secret pocket that React allow us to that React provide us as a way to remember things, okay, or as a way to remember reference without trigger a rendering, okay. So what we can do is that anytime you have this, I want you to now clear the interval here. Clear interval of whatever reference you have this. And then, okay, proceed to print this. And on the stop, I want you to handle this. So you might wonder, it's like, okay, now since this is going to be showed, all right, we need to actually look at this difference between the time now and the current time, because this function will call, this function will run, or now React anytime it will render this function. So now anytime we set the state now, React will re-render this function for us. So it is interesting to use now as a variable here, JavaScript variable, and then calculate the new value there, and then update it to this. So this is when we say if see. So how can now we show is this time properly, okay? Because at the end of the day, what is gonna show this is I would say the now, okay? Okay, we can say is to 0, right? We say star. Exactly, which is it is star. But it's saying now, okay, we receive this time step. Okay. Okay. And followed by the start time, which is 0 as well. Okay. So the whole point of this is because we have now 2 times here. Okay. Because we have 2 times here. We're saying, hey, if the second pass if the second pass is less than now, we would like is to calculate if this is the second that is less than now, I want you to now is recompute this second. So how so? By say second passes, it'll be now to this. The difference between the start time minus now, is less than now, which will be, and then in fact it'll be is now minus start time, because now we got the difference. We're gonna say this is 60. I'm not sure how to calculate this. To me it's like quite interesting. If the start time is null, this logic. So if the start time is different from null, which means that and now is different from null, we say, all right, now it's time to calculate the second passes. That'll be is the now minus start time, assuming that this will be incremented and we want this to integer. What is the value of this date now? What is the value of this date now? It return is a number. Milliseconds. Yep. So it return a number representing the time step in millisecond of the current time. So now this is millisecond of the current time. So now this represents the millisecond of the current time. So for now and the start. So I think this is supposed to be is exactly now minus star. It will give you integer, because you have now is the milliseconds. We need to actually calculate that. So how you transform from milliseconds to seconds? Divide 60, right? How many milliseconds are in a second? This is now the scale. How many milliseconds in a second is 1000? But and because we are not updating is every 10 milliseconds, we are updating is every 10 milliseconds. We're gonna get is this. As a way to get now the seconds here, but this will give us is the seconds here. Start time. Oops. second pass is equal to the now minus start time. So we're actually verifying that this is, if they exist, great. Now, second pass, which is this, start time and now. Second pass here, now and start time. Wow, what the F is this? Because this represent is milliseconds. And we're going to update this every time with an integer. So we want is to compute this. Oh, of course. Exactly. Exactly. But because this must be shown is because we're getting is this per, this is the millisecond, okay, and I want you to now show this is per minute. I mean, it'll be like this. Exactly. Or if you want to make much more accurate, like this. To show them by milliseconds. So here we're showing is this by millisecond. And if we want to now update that state, exactly. Is this minus this because it returns in millisecond, and we get is that data as it is. So if for some reason we not fix that to 3, we're gonna get is a huge okay, it's actually showing is that. But I think this is quite interesting as a way to now being able to create is a stopwatch. But now we want is to now reset that clear, tell the browser, hey, clear the interactivity. I want you to stop doing, and I want you to stop send or evaluating this callback. We use is a timeout ID using this special pocket ref for that, call the null, and then assign this special pocket that is not going to trigger rendering under the current, which allows us is to store or remember things here, and then we can do is this passing is the current ID of the timeout as a way to say, hey, I want you to now clear the interval browser or any JavaScript environment that it implement this for me, and make use of this. So that's quite interesting. So that's one of the main use cases of useRef. Since the interval ID is not used for referencing, you can keep it in a ref. You can keep it in a ref. So difference between ref and a state. As we mentioned, well, states are immutable, ref are immutable. You can use that when you want to remember things that not trigger re-renders. So in this case, it's actually trigger a re-render. So that's it. We also look at how can we don't need to trigger a re-render. Okay, so it actually won't trigger a re-render, but it's now updating the value behind the scenes. Okay, how does useRef work inside? Although both useState and useRef are provided by React, in principle, useRef could be implementing on top of the useState. And you can imagine that inside of React, useRef is implemented like this. So you have an state where it's going to expose you the initial value and expose you only the ref. So you don't trigger a re-rendering here. During the first render, useRef current value will be the initial value. This object is stored by React, so during the next render, the same object will be returned. Note how the state setter is unused in this example. It is unnecessary because useRef always need to return the same object. React provide a built-in version of useRef because it is common enough in practice. But you can think of it as regular state variable without a setter. If you're familiar with object-oriented programming, ref might remind you to instance field. Instance field. But instead of this something, you write something dot current. So you can think of this as a as instance field. When to use a ref? Typically, you will use a ref when your component needs to step outside and react and communicate with external API. Often a browser API that won't impact the appearance of the components. So any API that don't impact the appearance of our components, so for example, timers, fetch, beware with that. But most likely it's with timers. DOM manipulations, okay, and storing objects that are necessary to compute or to calculate GSX. So best practice for ref. Treat ref as an escape hatch, as a way to step outside of React. Ref are useful when you work with external system or browser API. If much of your application on data logic relies on ref, you might want to rethink your approach. Don't read or write ref current during rendering. If some information is needed during rendering, use a state instead. Since React doesn't know when ref.current state, when.current ref change, even reading it while rendering makes your component behavior difficult to predict. The only exception to this code is like if the current element does not exist, okay, get the new things, which only set the ref once during the first render. Limitation of React states don't apply to ref. For example, state act like a snapshot. A state act like a snapshot for every render and doesn't update synchronously. Exactly. So React state act as a snap during render. Okay, React state are snapshots for every render and doesn't update synchronously, which means that you're gonna get the next state update in the next render. Two important things to remember here. States are state act like a snapshots for every rendering. And I say during rendering is that state act as a snapshot for every render, and they doesn't update synchronously. The state update, the state value updates in the next render. So that's quite interesting. That's quite interesting. This is because the ref itself is a regular JavaScript object, and so it behaves like one. So ref and the DOMs, you can point to ref for any value. The most common use case for ref is to access a DOM element. For example, this is handy if you want to focus an input programmatically. When you pass a ref to a ref attribute in the JSX like div ref my ref, React will put the corresponding DOM elements into my ref current. Once the element is removed from the DOM, React will update ref.current to be null. You can read more about this in manipulating the DOM with ref. Ref are an escape hatch to hold onto values that aren't used for rendering. You won't need them often. A ref is a plain JavaScript object. You can ask React to give you a ref by calling the useRef. Ask me, hey, give it to me. Like state, ref lets you retain information between re-renderings of a component, exactly, but it doesn't trigger a rendering. Again, this is a special use case for that. And like state, so state act like a snapshot on every rendering. Oh my God. So state like as a snapshot on every render, and state act as a snapshot of every render, and they are not synchronized, and they doesn't update synchronously. Makes sense. Makes completely sense. Totally sense. Okay. Interesting. Very, very interesting. Very, very interesting. Okay. And we're back. We are back here. How's it going? So yeah. So now that we look at how can we escape the hatches, or how can we uh, make our React component step outside uh, to control and sync with external systems. So for example, browser APIs as a way to focus the input using the browser API, or to play and stop the again, all of these are very specific things that React team required to do. Okay, that React teams required to do. That's what they call this advance. So if you want to now control and for example DOM elements, we use ref. We're going to explain that. Also, if you want to control if video players that are implemented outside of React, again, any browser DOM API or any browser API that you don't need to keep track, or that any browser, any object that is not needed in GSX rendering, any object that is not needed in a GSX rendering, or for example timeouts or DOM elements, are a good candidate for useRef, because useRef is the secret pocket that allows to store between re-renders without trigger a re-render. So a good example of that is when you're working with timers. You know, that's a very common use cases. The other is when you want this to interact DOM elements. Again, also true. And when we're working with the bounds, you know, and when we are working with the bounds here, fix the bouncing. And where we are working with the bouncing, the bouncing versus troll. That's interesting. Oh, mock service worker. Mock service worker. Interesting.
MSW is an API mocking library that uses service workers. Here's how it works. When your application performs an HTTP request, it gets intercepted by the service worker. But instead of resolving response from cache, it returns the mock response you want. Since the interception happens on the network level, your application knows nothing about the mocking. Written in TypeScript and having a rich support of REST and GraphQL APIs, MSW is your next favorite tool for development,
Exactly, from service worker.
testing, and debugging.
Because it's using service worker for that. No more stopping of fetch actions and React query.
We have a React application that renders a list of cart items.
MSW.
That's quite interesting. Golden sponsor, GitHub, Codacity, Worklib, and Chromatic. Technology Radar, and Open Source Aware. Not on the current edition. That's quite interesting. But this doesn't have any too much adoption here. And I could instead live alongside the rest of my app. For testing as well makes SMB a huge productivity booster. Epic Web Dev.
Hi there, my name is Kent C. Dodds and I'm so excited to share with you epicweb.dev, where I want to teach you everything you need to know to ship modern full-stack web applications. So epicweb.dev.
Okay. It's an academy. Testing fundamentals, full stack fundamentals, data modeling deep dive, authentication strategy implementations, data modeling deep dive. We're designing database, managing relationship data mutation and optimization, professional web forms, full stack foundation, and all of this. good for KMC dot. But what is relevant for us is now, take a look at this. It was in 2019 that the bounce versus trolling, definitive visual guy. And now he have his Discord where he released. I'm a software engineer here, starting in, okay. In the Ukraine, I get it. Ukraine. And the fair promise. That's in 2023.
As a standalone layer. So if you think about how you control your network during testing, for example, well, you have a bunch of these different tools, right? You have tools like Playwright and Cypress and VTest and Jest, and they all ship with their own API mocking capabilities, which are amazing. But the thing is, once you achieve this full test coverage of your product, you start to notice that this network descriptions you do, they kind of repeat. In essence, you just want to do one thing, describe the network, but you using different APIs from different frameworks. But how do you do that? How do you do that? And if it's application/JSON, it will try to parse it and give you the object back. So we're accessing the name property here. Thing that's not standard JavaScript. So let's do just that. In JavaScript, you use this call signature to handle requests. The response function, and you can say, well, if it's not broken, just don't fix it. Not a big fan of that. In fact, working in open source, I think has taught me a much more important motive. It's that if it's not educative, don't ship it. Because my goal as an open source maintainer is to share my ideas, but I also want all those developers that like my ideas and use my ideas to get better at JavaScript, at the language, not in my little projects. Because if you think about it, JavaScript has got a lot of improvements over the years. And you can see this modern era has JavaScript parts in it. I set off on this mission, like the primary, it's a fantastic API. Or you may be using XML HTTP requests really on third-party libraries, sometimes according to the specs, sometimes not. Because, yeah, you can represent
the fair promise. Okay. He's working on Epic Web. That's quite interesting. That's quite interesting. All right, cool. But again, what we really care about this personal, cultural, engineering. Debugging like a proxy. Yep, using the proxy to debug your app. Building a tree shakeable library with rollup. Interesting. He began in 2028. All right. Okay. And the proxy API. Exactly, when you now, which is what it's using, for example, is React, Vue. Is what is using Vue behind the scene. Fundamental operations of the object. The target and the handler. And the handler. The inoperator return true in the specified property if the specified object and its prototype change. That's interesting. And it is prototype change. Hey, is this property R in the object on its prototype change? Yeah. Okay. That's quite interesting. And he look up over that. Cannot be used to search value in other collection to test if you can certain exists an array like this or has. But this is for objects. Holy crap. Hey, is this now in this object or in the prototype change? Alright, it'll make sense of this. It'll make sense of this. So return that, otherwise return 37. So you have now this, say hey dot A and dot B is undefined. So if the props, anytime you get that, not up forwarding. This is a very interesting API as well, but again, this is not what we are looking for, which is the bouncing in here. And how can we work with ref, as well as how we can manipulate the DOM with ref, which is one of the things that one of the most common use cases with ref, which is working with timeout like this, or working with timeouts of D and manipulating them with ref. Something that is quite familiar, because now, for example, Vue allows you to manipulate that as well. So React automatically updates the DOM to match your render output. Okay. So your components will often need to manipulate it. My question is that
you know, you went from Reddit to Microsoft to,
Netflix after.
Sorry, Reddit to Netflix to Microsoft to Stripe. Like, what do people see in you that, like, why are people hiring you?
I guess that's a stupid white guy failing up, I think is the answer to your question. No, I mean, it might be. Actually, you know what? I'm gonna.
You could talk. You know, you could talk to like each one a little bit individually.
Sure, yeah.
I am the man. Or, I don't know. Because I am the man. No, but jokes apart, is like, I can elaborate a little bit more, but as a way to shed some light on that, as well as some shadow when you need to. But you can summarize that you want to look for the truth. You're looking to find out things and how that works and the mechanism and all that kind of thing. Basically, is that, you know. Bye-bye. All right, so manipulating DOM, the DOM with ref, so we can tomorrow finally jump into the use effect, and you might not need an effect. Okay, so React automatically update the DOMs to match your render output, thanks to the rendering mechanism. Trigger rendering and commit, and during the commit phase is when the reconciliation happened, based on the virtual DOM. And the virtual DOM is just these computer techniques that some libraries use as a way to represent the ideal render tree and keep in sync with the real DOM. So anytime now React render your component, it creates that'll be a very interesting question here. Anytime a React render your component tree based on a state update, it will create a VDOM. I'm assuming yes, because exactly, it creates now a virtual DOM that now it is going to be used as a way in memory, that now is going to be used to compare with the old virtual DOM. And through the reconciliation, which is a fancy name to say, hey, what will be the subtle difference between these components? And I'm going to apply an algorithm to, or the different algorithm as a way to, yeah, okay. So it created a virtual DOM, exactly. When during render, it created a virtual DOM, which now contains all of this information relevant to the component tree, as well as fiber, which is an internal object that has more information about this. And when it's going to now see the difference between components, between virtual DOMs, the previously and the newly generated, then it's going to apply this reconciliation phase as a way to say, hey, now that I know what will be the specific elements that I need to update, then it now sync with the real DOM. And this is a very interesting process to know behind the scenes, because anytime you're going to create components with an state, when you set that state, you know what is doing and over and over and over and over and over again. So subsequent versions of React will make them to understand that much more easy and find better ways to actually say, okay, or make it easy to understand all of this incremental change or add-ons that new version of the framework come out. So manipulating with the DOM. So React automatically updates the DOM to match your render output. So your components won't often need to manipulate it. However, sometimes you might need to access to the DOM elements managed by React. For example, to focus a node, to scroll it, or measure its size and position. There is no built-in way to do these things in React, so you will need a ref of the DOM to manipulate them. Especially for this specific case, to focus on a node, scroll to it, and measure its size and position. Okay. So, how to access a DOM node managed by React with the ref attributes. How the ref GSX attribute related to the useRef hook. And how to access another component's DOM, and in which case it's safe to modify the DOM managed by React. First, because we know how can we escape hatches or step outside of React components as a way to control or sync with external systems. So for example, when you want to focus an input using the browser API, or you want to now play or stop the, in fact, something that we're gonna see here, we're gonna play or stop is the video player implemented outside of React, or simply you want is to connect and listen to message from a server. So this escape hatch sections or this particular hooks allow you to do this. One, if the useRef, where this is now like a secret pocket where it can store or remember information without trigger a re-rendering, okay? But it stores information between re-renders, okay? So, because a state acts like a snapshot on every render, and they are and they act as a snapshot on every render, and update, and it doesn't update synchronously, okay? With ref, we can have now these secret pockets, okay? So React won't keep track of this, and we look at what is the main use case to use. So now software developers in Facebook decide to come up with this, and that is, for example, timeouts ID, fairly common. Also, when you want to select is canvas ID, okay, as a way to paint these elements, or as a way to hold a reference of this canvas and then points to that. A good example is this intermediate React here, which is a course taught by Brian Holt. Yep, a course taught by Brian Holt. No, is here. Value proposition. The idea of useRef is to keep track exactly the same thing that is triple equal to each other. This is the value proposition. Okay. Avoid recreating context and that kind of thing. How to avoid is null check when initialize useRef and the uses here. Followed by this, a caveat. You can mutate the ref current property unlike the state. Strict mode, React will call your component function twice in order to help you find accidentally impurities. This is the development only behavior and does not affect production. Each ref object will create twice, but one of the versions will be discarded. If your component is pure, and as it should be, this should not affect the behavior. So this is not describing more about useRef, but again, The idea here is that if you want to keep tracks exactly the same thing with triple equals. So, real life example. Okay, allow us to grab and hold a specific DOM node and referencing a value using that, which is a very niche use cases. You know, another good example here is that when we want to reference in DOM elements like that, okay, for example, yes, like this, and here we want now is to mount and here we want is to now mount this render target current append on child as a way to now not only hold a reference but actually add some DOM elements here. For example, with the rendered DOM element, you want is to now dynamically append this. You want to dynamically append an elements to get rendered. That's quite interesting. That's quite powerful and interesting. Yeah, bro. Oh my god. But again, very narrow specific use case of using is the useRef. Okay? We're going to just describe briefly about this. Okay, so how now by looking at this particularly specific use case of useRef, which is useful when you want to keep track exactly the same object using triple equals. Okay, so this is how you can use that to manipulate DOM elements. Here, the useRef hook returns an object with a single property called current. Initially my ref.current will be null. So when React create DOM, when React creates a DOM node for div, React will put reference to this node into my ref.current. You can then access this DOM node from your event handlers and use the built-in browser API defined on it. Okay, so far so good. Okay, so we understand now how this things actually work. Yeah, there's no actually thing here. This is how you can now by holding as a reference or by manipulating its DOM elements, where actually it can give it to you, now you can have access to this and actually perform some of this. So browser building elements like this, which is great. And also you can see yourself familiar with this, with the elements after. Okay, insert a set of no object or string in this child list for that after. Animate. An element interface animate method is shortcut method which create a new animation, applies to the elements and place the animation, and in return a create animation object for yourself and the keyframes. Web animation APIs. What you're gonna have is the instant property, current time, effect, finish, pending, playback, ready, replace state, instance, methods, all of played, okay, or pause. Okay, as a way to have much more fine control about this. Event, question. What is the browser compatibility of this? They actually remove Internet Explorer? How dare you? Okay. So now that you have is the web API and okay, web animation API. So my question is that 3GS it's not 3GS, is GSAP here is now this using effect decor method config create default. And the animation API, bro. Web animations in GSAP. I saw this tweet today. SVG animations and CSS capability. Again, because they are very, very specific use case. Because they are very, very specific use case. Because it's this product, bro. The echo loading spinner. And that was quite old, by the way. Yeah. So yeah, again, we are looking is now here at this animation. I think they are putting is this as an overflow hidden. That's right. It's now using the timeline max. And this is how now you can imperative control this. Of all of those elements, and now it allows you to animate that, which is exactly what we're looking at, this kind of thing. For example, here, the animate. So by exploring here a little bit more of how can we actually, at least it's just, it's a curiosity. Okay, by exploring this curiosity here with after and animate, the kind of thing, we were now able is to understand what are the property and what are the fields and methods that we can have access to. And as a way to make it this much more easy and meaningful to work with. So by looking now at the element here, specifically this, which is part of the web API, the element, specifically the DOM, okay, and how now the DOM exposes several interfaces as a way to make our life much more easy to work with when you need to construct or to interact to this, like element here, okay, like element here, which comes from the event target. Element is the most general base class from which all elements objects, the object that represents elements in the document, inherit. It only has method and property common to all kind of element, more specific elements inherit from the HTML, from the elements. For example, HTML interface is the base interface from the HTML elements. Similarly to the SVG elements, interface is the base of all the SVG elements. So all of these elements here, which can think as the base class, all of these elements have access to all of this property here, which is a ton of property, okay? As a way to now know is the client high and the client thin, you're starting to understand now what the things is going on, as well as the instance method as a way to animate this element as well. This is quite interesting and quite compelling here. And also animate is fairly new this. Fairly new to this. You know, you can add not only animation to this component, to this series of component as well. So by saying, hey, you have now much more fine control of what's going on behind the scenes. Again, the whole purpose of using React is because now it allows you to declare all of this component declarative, which means that we don't need to actually have full control of that, or we have to be explicitly how we want to do the things. And if we need to, well, we can use the ref for that. So this example now illustrates that how can we now, by manipulating DOM elements, okay, whether it is not only HTML elements, but also math elements, okay, math elements, as a way to show is, well, some some elements like that. So you have math element here, attribute style map, style element, and that kind of thing. It actually exposes this math element, the markup language. Interesting. For good. This is something that you barely use that, you know, but it's important. I mean, unless you're working for researchers, companies, and that kind of thing. But this is interesting that you have now this markup language. Also, you can take a look at the reference here. So we would say markup language, ML, and anything that ends with ML is a markup language. Markup language, markup language. You also have the extensible markup language. Okay. Except for SVG, which is not a markup language. But this XML, which is an extensible markup language, okay, extensible markup language is a strict serialization of the DOM. So in any case, we were looking is at that this allow is to render this kind of thing. For example, here, the math home. It allows us to express this kind of object here. That's quite interesting. It's very narrow specific as well. Okay, not everybody are using that, as you can imagine. Okay, but again, it exists. This is the markup language definition. 25 years of the markup language. It was in and it was in April 1998. Interesting. Very, very interesting. That's quite interesting. In Spain. Yeah, very, very, very specific, bro. Browser developer WebKit focus in Chromium focus. Anyway, now we'll look at how can we work with this, which is actually quite interesting, fairly good, by the way, totally. By the way, yes. Okay, so that's right. And the other is scrolling to an element. Here, it say because now you're picking this element. I'm assuming that you're picking this element here. No, you're not. Oh, exactly. You're picking this element, And now these elements allow you to scroll into views. We already closed this. I should. Not the web API animation. In fact, we want to look is at the web API, the element or the DOM. The DOM API, followed by its interface. We can take a look at the interface here, as I described. The type of objects that are available. Exactly, the type of objects that are available and the APIs. For example, the DOM API here. And now we want us to take a look at a specific interface, which is the element, right? The element. And when we pick this element, now we can have access to all of this property here and methods. So they describe here is on scroll. So scroll behavior. You know, so scroll behavior. Scroll into view. Scroll into view. The elements interface scroll into view methods scroll the element ancestor container such as that the element on the window scroll into view is visible to the user. So this will allow us to go through that, navigate to that. So instead of actually saying, hey, this is the instance behavior, I want to make it smooth behavior. Right? Can we change this? No. Are you not allowing me to change that? So for example here, if I want to change the behavior here and say, hey, make it smooth to that. You know, hey, go to that element. Go to that element. You know, but the idea here is that now you can have access to the scroll into view. Hey, I want you to now make this button to what I want. Okay, because you need to get outside of this. Okay, this is how you can do this. Hey, scroll into this. Get this element by the ID and scroll to that. Interesting, interesting. Very, 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 very interesting. Very, very, very interesting. So this is a method here. So when you click here, I want you to now trigger this. I want you to now go to that element. Go to, or go to bottom. And go to top. Again, for very specific use case here. So for example, like time ID, I want to hold a reference from this. I also want to now hold an element here as a way to focus that, or as a way to scroll this, scroll to that position. Because again, React allows you to describe is the UI, but you don't have the DOM, okay, which is something that you can write by your own, as a way to interact with that. You can use ref for this, and then you say that kind of thing. So here when you run, oh, I mean is the nearest, oh, start, or the start. Okay, so now you can start to work with this. You now start to work with this particular API. Smooth, auto. So the behavior is smooth, and the block define vertical alignment. One start, center, end, or nearest. The vertical alignment, and the other is horizontal alignment. Center. So the block define is the vertical alignment. Exactly. And the other is center here. No, you say then is nearest. Hey, I don't want you to move that. I don't want you to move that. How to manage a list of ref using a ref callback. In this example, there is a predefined number of ref. However, sometimes you might need a ref for each item in the list, and you don't know how many you will have. Something like this doesn't work. Something like this wouldn't work if you have many ref for that. This is because hook must be called at top level of your component. You can use ref in a loop, in a condition, or inside of a map. So you may wonder, it's like, how can we manage a list of ref using a ref callback? One possible way around this is to get a single ref from the parent elements and then use a DOM manipulation method like query selector all to find the individual child node from it. However, this is brittle and can break it down structure change. So you don't want that. The other is to pass is a function. Okay, is to pass a function to the ref attributes. This is called a ref callback. React will call your ref callback with the DOM node when it is time to set the ref, and will null when it is time to clear it. This lets you maintain your own array of map and access any ref by its index or some kind of ID. So you can pass this as ref callbacks. You pass this a function, okay, of what elements you wanna render this. Instead of a ref of object like the one returned by useRef, you may pass a function to the ref attribute. See an example of using ref callback. When VDOM is added to the screen, React will call your ref callback with the DOM node as the argument. What the div DOM node is removed, React will call your ref callback with null. React will also call your ref callback whenever you pass a different ref callbacks. In the example above, node is a different function of every render. When your component re-render, the previous function will be called with null as the argument, and the next function will be called with the DOM node. Okay, this is when you want, when a strict mode is on, React will run one extra development only setup cleanup cycle. React event objects. And this is now ref callbacks here. Why is this? I think this is the reference here. Common components. ref callbacks, animation event, clipboard. Okay, clipboard, composition, drag event. Mm-hmm. 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 Okay. Reactivating objects and that kind of thing. Okay. Okay. Are supported for all built-in components here. This is now the reference of this. All built-in browser components such as div support some common props and events. Ref callback function. So it means that if this ref allows you to define is ref callbacks, if this ref is this ref allow you to define is this callback here. Okay. Is this ref allow you to define is this callback here, like so. Is this ref allow you to define some callback here? User staying is useRef. When you're going to make the callback, you define is on click, scroll to callback. But it's in here when you're going to define this. You're gonna say, hey, because now you are creating is a new collections of elements. If ref is current, it means that it means that you are going to initialize that. Okay. Now create this. Otherwise, return is the element here. So your storing is this. If you haven't stored that, okay. That's going to store that as a new map. So now here, we have now all of the reference that we need to, and we're going, okay, we got now the reference that we need to, and then I'm going to actually is set that, hey, this cat followed by this node, and that is, well, the cat is the element that you got that, and you're gonna set that to this node. What you're going to return now is this object here that'll be a map, okay, and this current object that we're going to get is a map where you can set that or delete that if the node is not present. So now when you are going to call that scroll to cat, you say, hey, it's going to create a new map, get map here, and it's going to now get the proper map as node, and now that it get the proper node, from the cat, okay, it's actually creating a new get here as a way, and then map.getCat, okay, which is a function here to actually verify that you already have some reference. If it is, okay, you're creating is an, okay, you're actually getting that. You're actually getting that map of reference. And if it is, okay, let now to actually get that. If it is, scroll to that on click, scroll to that element, to Maru, to Jellyrom, and to Tom. Exactly. That's pretty def. This lets you read individual node from the map later. Okay, and accessing another component's DOM. Okay, and accessing another component's DOM. So first we look at how can we now get a ref here from a DOM, from a node, okay, as a way to now not only focus the input on that, but also how can we create this, or how can we create this list of or this map of ref, okay, as a way to now keep track of these elements, and when that element is not present, you just remove that, you just delete that for that, because what happened is that it will create this on every render. It will call this on every rendering here. It will call this on every rendering. Okay, it will call on every rendering. What you want is to get a reference of all of these elements here. Hold that, store that in a map then, okay? And when you detect some event, well, perform something that is outside of React. In this case, scrolling to an element. Scrolling to an element. Enable, okay, scrolling to an element. Scrolling to an element. Apply any of these elements that is outside of React. Okay. Okay. Accessing another component is DOM, which is this. You gotta be careful with this when you're accessing here, accessing another component's DOM node. However, if you try to put a ref on your own components, like my input, by default you will get null. Here is an example demonstrating it, noticing how clicking the button does not focus the input. To help you notice the issue, React also prints an error like this. Is function components cannot be given ref. Attempt to access this ref will fail. Do you mean to use forward ref? Because it's a, okay, it's another hook. Check the render method of my form, my input. This happened because by default React does not let a component access the DOM of other components, not even for its own children, and this is intentional. Why this is intentional? As a way to prevent some misbehavior. Ref are an escape hatch that should be used sparingly, manually manipulating another component's DOM. Make your code even more fragile. Instead, components that want to expose their DOM node has to opt in to that behavior. And you shouldn't rely on these features. A component can specify that it's forward, it is ref to one of children's, and here is how my input can use the forward ref API. But by rendering this element here, okay, so by now rendering all of these elements here in your sections, okay, and the okay, so by rendering all of these elements here, don't overcomplicate things, man. That's all I'm gonna say. Don't overcomplicate things. So from this navbar, navigate to that. Get that element, identify, and then when you click that, navigate to that. When you click that, navigate to that. Again, skipping the hatches here. That's quite interesting. This is quite interesting. Totally. Okay, so now that we have this particular mindset of how we're going to, for example, enable this navigation in your landing page, which is a fairly common use case. Fairly common use case, exposing a subset of API with an imperative handle. So, all right. So using forward ref allow you to now have access to the DOM here. This is how it works. My input ref tells React to put the corresponding DOM node into input ref.current. However, it is up to my input components to opt into that. By default, it doesn't. So my input component is declared using forward ref. Oh, but forward ref in my input. Oh, okay. Give me the ref, forward ref. This opt into receiving the input ref from above of the second ref argument, which is declared after props. My input itself has the ref as it is received to the input inside. Again, this is if you want to access in another component's DOM node. Very narrow specific, man. Very narrow specific. You use the forward ref and then you wrap that component, my input, as a way to expose then that. In the sign system, it is a common pattern for low-level components like button, input, and so on to forward their ref to their DOM node. On the other hand, high-level components like form, in low-level components like button, input, and so on, it is common to forward the refs to their DOMs. On the other hand, high-level components like forms, list, or page section usually want to expose their DOM nodes to avoid accidental dependency of the DOM structure. But this is very specific to that. Forward ref, useRef, and use imperative handle. Exposing a subset of the API with the imperative handle. Use imperative handle. Only expose, focus, and nothing else. As a way to programmatically say this. Okay, so when React attach the ref, again, you shouldn't rely on this behavior too much. If you do, you should rethink about it. Yeah, when React attach the ref, in React every update is split in two phases. The render and the commit. That's right. So React call of your component, figuring out what should be on the screen by creating the virtual DOM. And then during the commit, React apply the change to the DOM by looking at the difference between those virtual DOM, the previous virtual DOM, and the current, the new generated virtual DOM at the rendering phase. And then he reconciliate that using the diff. And then reconciliate that using is the diffing algorithm, okay? And this new, and they apply the necessary change to the DOM, to the VDOM, and then now the VDOM is synced with the real DOM, update that, and now it renders properly. In general, you don't want to access ref during rendering. Let's go for ref holding DOM nodes as well. During the first render, the DOM node have not been yet created, so ref current will be null. And during the rendering of update, the DOM node haven't been updated yet, so it is too early to read them. React set the current during the commit phase. When is going to conciliate that before updating the DOM? Okay, which is on the conciliation phase, we assuming that. React set the affected ref current value to null. After updating the DOM, React immediately set the corresponding DOM node. Usually you will access ref from event handlers. Flushing state updates synchronously with flush sync. Consider code like this. you have a reference here, which adds, okay, flushing state updates synchronously with flush sync. Flushing. To rinse out. Flushing. Yeah, but this is to rinse out, wash out, wash. Yeah, rinse out, wash out, rinse out. Okay, lift ref the current last child scroll to view. List ref dot current last child dot scroll view. State updates are queued. Usually this is what you want. However, here it causes a problem because set2 doesn't immediately update the down. So the time you scroll the list is last element. Wait, what? Okay. So when you do a flush sync, you say, hey, set the text and set to do, and because this actually happening is after the commit phase, so now when you add new one, it actually go through that reference. Best practice for DOM manipulation with ref. Ref are an escape hatch. You should only use them when you have step up outside. Common example of this include managing focus, scroll position, or calling web APIs that React doesn't expose. And the TLDR of that is like that. So to illustrate this problem, this example includes a welcome message and two buttons. The first button toggles its presence using conditional rendering and state. You will usually do in React. The second button uses remove DOM API to forcefully remove its DOM from the outside on React control. Avoid changing DOM nodes managed by React. However, this doesn't mean that you can call it. So again, this is very, very specific. Very, very specific. Very, very specific. Very, very specific. You shouldn't rely on this, by the way. You shouldn't rely on this. Okay, when you want to focus on input. Okay. So, that'll be all for this video. Take care. Bye-bye.